In this video, you will be learning about the law of conservation of energy. The essential questions we will be looking at are, what does it mean to do work, and how does energy change forms? By the end of this video, you should be able to explain what is meant by the law of conservation of energy and apply the law of conservation of energy to various situations. The law of conservation of energy states that energy cannot be created or destroyed. It only changes form. There are several different types of energy. Mechanical energy includes all kinetic or potential energy, both gravitational potential energy and spring potential energy. There's also internal energy, which includes heat, light, sound, and every other type of energy that can be formed. In an ideal system, the sum of the mechanical energies is always constant. We are going to be focusing primarily on ideal systems, which means kinetic energy is going to be converted into potential energy, and potential will be converted into kinetic energy. However, in any system, whether it's ideal or not, the total amount of energy will be conserved. That's once you take into account internal energy, heat that might be produced due to friction. An object moves with no friction or air resistance, so we know we're dealing with an ideal system. Initially, its kinetic energy is 10 joules, and its gravitational potential energy is 20 joules. It asks, what is its kinetic energy when its potential energy has decreased to 15 joules? Well, we know that the total energy is equal to the potential energy plus the kinetic energy. And at the beginning, we know that the potential energy is 20 and the kinetic energy is 10. So the total amount of energy that I have is 30 joules. And that must be the case at any point in time. If its kinetic energy has decreased to 15 joules, then to add up to a total of 30 joules, its kinetic energy must also be 15 joules, because 15 plus 15 gives me the 30. The next question is, what is its potential energy when its kinetic energy has decreased to 5 joules? Well, if I only have 5 joules of kinetic energy, and I need a total of 30 joules of mechanical energy, the other 25 joules must be the potential energy. This is basically what the law of conservation of energy is stating. However, we can also be plugging into our potential energy and kinetic energy equations to figure out what these actual energies are and to find things like height and speed and spring constants and compressional distances as well. But this is the basic concept and the only new information in this section. This says a baseball player hits a 0.15 kilogram ball over the outfield fence. The ball leaves the bat with a speed of 36 meters per second, and a fan in the bleachers catches it at 7.2 meters above the point where it was hit. Assuming frictional forces can be ignored, calculate its speed just before it is caught. Since potential energy has a relative zero, we can just call that zero potential energy the level at which it was hit, because that's where it's telling us the height change from. So that means initially, my potential energy plus my kinetic energy is the total amount of energy. My potential energy is 0, plus my kinetic energy, 1/2, times the mass of the ball, 0.15, times the velocity is 36 squared, gives me a total energy of 97.2 joules. That total amount of energy must stay the same overall. My final energy, again, is going to be the potential energy plus the kinetic energy. And my potential energy is gravitational potential energy, which is going to be mass times the acceleration due to gravity, so 0.15 times 9.81, times the change in the height, which is 7.2, plus my kinetic energy, 1/2, the mass, 0.15, times v squared. But remember, this has to equal the 97.2 joules that I had initially. So when I take that equation and solve it for velocity, I end up getting that my final velocity would be equal to 34 meters per second. So again, all I need to do is remember that my total initial energy must equal my total final energy. Look at what potential and kinetic energies are in the system at the initial and the final times, and plug in those actual formulas. Mass times gravity times the height for potential energy due to gravity. I could also use the spring potential energy equation and the kinetic energy equation as well, and solve for whatever the unknown is.